my dear grade 10 elite students to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my term 3 students to today's important and must watch video. In this session we are going to be covering learning objective 3 from part 1 where we are going to find antiderivatives. So let's start from the video and make sure you have watched the previous video which I made on learning objective 2 before you proceed with this video. Also, a humble reminder to like, share and subscribe to the channel if you are benefiting from the videos and finding them useful. So let's start on learning objective 3, finding antiderivatives. These questions which are taken from your math book on page 199. These are 10 questions, so we are going to cover some of them here and some of them on the next slide. But to solve all of these questions on antiderivatives, we are using the same formula called power rule. So I will write the rule for you here, and remember this is a power rule that is used for antiderivatives. It is a formula from integration. So don't confuse with the power rule of differentiation. That is different and this is different. So the antiderivative of x to the power n, if you have something like this where you have raised to a power, that's when you apply this power rule. So the antiderivative, also known as the integral of x to the power n, is denoted, I will write it in this way, integral dx. When you apply the power rule, what happens? The power increases by 1 in the power, and it also divides by n plus 1. So this is the rule you need to remember, which we are using for solving all of these questions and for finding the antiderivative. Let's do the first one, answer 1 here. So to find the antiderivative of fx, that means x to the power 5 dx, we are going to apply this formula, means we increase the power by 1, so 5 plus 1 divided by 5 plus 1. And remember, because we are finding the antiderivative, the constant of integration is going to come, so I add c. So this is x to the power 6 over 6 plus c. That is the complete answer of question 1. Now we'll do for question 2. Let's do it here. So for answer 2, again I have to find the integral of minus 5b minus 3. Now if you see, the variable here is b, so I will write db with it, and you can split it into two parts. Minus goes outside, 5b db minus 3 integral dt. Now the negative will be as it is, b is raised to the power 1, so we apply the power rule, 5 comes out, it becomes b 1 plus 1 over 1 plus 1. And minus 3, there's nothing here, only db, so it will become b, and then you add the constant of integration. So the final answer for this question is going to be minus 5b square over 2 minus 3b plus c. That's your answer for question 2. Let's do question 3 here. So for question 3, if you see, f of z is given in terms of cube root of z, so I can write it in the terms of a power as z to the power 1 by 3. So let's calculate the integral of, or the antiderivative of this. So the power here this time is a fraction, so when you add 1 to it, we are going to change the power accordingly. Don't forget the constant of integration, c, always. I will just make a boundary here so that you don't mix it with the previous question. Okay, so now we'll write the final answer here. Remember, 1 by 3 plus 1 is a fraction, and if you simplify it, it becomes 1 plus 3 by 3, which is 4 by 3. So that means this is the reciprocal of 4 by 3. In the next step, it goes up, so it becomes 3 by 4 z to the power 4 by 3 plus c as the final answer. So we've done question 1 to 3 here. Let's do the remaining questions in the next slide. To the remaining questions now. I'm going to be a little fast because I've already explained you in the last slide the power rule now. So we are going to complete the questions here. So for fourth question, again we use power rule. There are powers involved, as you can see, 4, 2 and so on. So the integral of 1 by 4 t to the power 4 minus 2 by 3 t square plus 3 by 4, and the variable is t, so I will put here dt as well. So when we do that, we apply the power rule. 1 by 4 comes outside. T to the power 4 becomes plus 1 over 5 minus 2 by 3 t cube over 3 plus 3 by 4 t. So this is going to be your answer. Let's do fifth one. And before we do that, let's partition this so that you don't miss the answers. Okay, so for fifth again, we are using the same rule, that is power rule. So it becomes 3 by 4 r to the power 2 by 5 plus 1. Now this is a fraction power, so you have to be careful while taking the reciprocal, plus 5 by 8 r to the power 1 by 3 plus 1 over 1 by 3 plus 1. That's how you apply the power rule, plus r to the power 1 by 2 plus 1 over 1 by 2 plus 1. Now be careful while taking the reciprocals. So this is going to be 3 by 4. The power here becomes, when you take 2 by 5 plus 1, the power becomes 7 by 5. And this here also is 7 by 5. So in the next step, 7 by 5 reciprocal will become 5 by 7. So when you multiply, this will come out to be 15 over 28 r to the power 7 by 5. Let's come to the next term. 5 by 8 already was there. When you take the power and the LCM, it becomes r to the power 4 by 3 over 4 by 3. So take the reciprocal, multiply. 5 gets multiplied with 3 to give you 15. 8 gets multiplied with 4 to give you 32. R to the power 4 by 3. Let's write the last term. So here the power becomes 3 by 2. So it is going to be r to the power 3 by 2 over 3 by 2. Reciprocal of 3 by 2 is 2 by 3. So this is the final answer. Don't forget the C, which is constant of integration. Everywhere it will be there. So that completes answer 5. Let's do answer 6 here. For answer 6 again, we are doing the power rule. So it becomes 2 by 3. So let's solve question 6 to 10 using power rule. For question 6, the answer will come out to be u to the power 6 divided by 9 plus u to the power 4 divided by 24 minus u to the power 2 over 5 plus c. Similarly, for 7, the answer will be 2a to the power 4 plus 5 by 3 a to the power 3 minus 9 by 2 a square plus 3a plus c. So every time we are adding the constant of integration. I will do answer 8 in great detail for you because it's a little different as you have the powers in the denominator. So when you have the powers in denominator, first you change it into a negative power. Make it on the numerator and convert the question in this manner, and then you apply the power rule. So now when you apply power rule, the variable is d, so it will be dd when you apply the power rule, and this will come out to be 12d to the power minus 5 plus 1 over minus 5 plus 1 plus 5d to the power minus 3 plus 1 over minus 3 plus 1 minus 6d cube over 3 plus 3.5d, and finally the constant of integration. So the final answer on simplification and cancellation would be minus 3 over d to the power 4 minus 5 over 2d square minus 2d cube plus 3.5d plus c. And now let me give you the final answers for the last two questions also. So for answer 9, the final answer would be 4d to the power 4 that's all in this video for grade 10 elite, where we had covered the learning objective number 3 and found antiderivatives. I hope you found the video useful, and if you did, give it a thumbs up, share it with your friends who are giving the math exam very shortly so that everyone can benefit from these revision videos. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye bye.